Today, the Presidency University Physics Society is going to present another talk. We have our presenters today. The first talk will be presented back to you guys by Debanjana Mukherjee. I would like to call Debanjana Mukherjee to start the presentation today.
Good afternoon. I am Debanjana Mukherjee. I will be presenting on development of an innovative spectrometer for experimental study on Rayleigh scattering. So I will be talking on the theoretical background behind it and what I have done and finally at what result I have reached, how it supports the theory and so on. So firstly we need to know what is scattering. We all know that light travels in a straight line, and while traveling, it interacts with some particles like water molecules, dust, and so on. And the interaction it happens, it makes the light change its direction, and this is what we call scattering. And the particle it is interacting with actually decides the intensity and the nature of the scattering. So based on that, we can classify the scattering. Like if the particles it is interacting with are much large, then it doesn't depend on the wavelength. Then we call it scattering. And if the particle is much smaller than the wavelength of the light, then it depends strongly on the wavelength. This is Rayleigh scattering, and this is what I will be talking about. So the scattering intensity during Rayleigh scattering varies inversely to the fourth power of the wavelength, and from here we can easily say that the shorter wavelengths scatter more than the longer wavelengths. My main goals behind this experiment was to set up an experimental setup and then record the spectra and plot it to find out how close it is to the theoretical value, and finally build an innovative spectrometer using CAD modeling. So this was my experimental setup. This is a black box within which I have kept a cuvette field of water, and I have given lights from different directions for the scattering to be happened. And this is the lens, and this is the grating. This grating is actually a broken part of a CD. We have broke it from a CD and used it as a diffraction grating. And we have used two different lasers, one green laser and one red laser, and a filament bulb. So firstly, we were using some helium lights, but it has too less intensity for this experiment. I'm not saying that helium lamp is not ideal for other experiments, but not this one. Then we used some like torch lights, but that was not also ideal for this experiment. So we shift to filament bulb. So first of all, we recorded the direct beam and then the scattered beam, and used some image software to process the data and plotted it to find out at the result. So these were the images we were captured using our normal Android mobile phones. This is the picture I've captured of direct ray without laser, and this is with laser. And for the scattered ray, this is without laser and this is with laser. So from with our naked eye, it is almost impossible to detect which one is scattered light, which one is direct ray. So we used a software called ImageJ, which gave me this plotting. This peaks are due to the lasers, and this large peak at the middle is due to this white, due to this bright white part. And this is what I plotted here. Actually, from this image, we collected some data and plotted it using Python coding. Maybe all of you know how it is done. So it is how I plotted it. And the slope I have received from here is minus 3.69, which is almost close to minus 4, which supports the theory that the intensity of scattered light varies inversely to the fourth power of the wavelength. So the experiment was not a failure. I succeeded to prove how close it is to the theoretical value. But still, it was not that much close to minus 4, like minus 3.69. Definitely, there were some reasons which caused this deviation. So, the reasons were the calibration errors, and although it worked in a complete dark room, but still some lights are always there, which caused some errors. And inside the cuvette, there were also multiple scatterings, and definitely, there were alignment inaccuracies because we were working with different tools, like not a robust structure. It was different items we used to set up the experiment. So, to solve this problem of alignment inaccuracies, I designed a 3D model using AutoCAD software, which helped us to solve this alignment inaccuracy problem. So, this is my 3D model I have designed, and you can see I have taken photos right from different angles, and it had a place for holding the cuvette and keeping the light. It has different laser holders, and this one is the lens holder, and this one is for holding the grating. This grating holder is movable, we can move it. Though it is not a video, it is just some screenshots from where I have designed it. So I can't show it moving here, but it can be moved, it is movable. So that we can take the image from different positions. And so finally I designed a 3D model using which we can do the experiment of Rayleigh Scattering, and then capture the images and study on it, and really plotted it and tried to find out how close it is to -4, which supports it slowly. This experiment helped me to learn how data analysis, spectroscopy, CAD analysis, these things are done, how to build a 3D model, and so on. And this can be used for also like different wavelengths of light. I have used just red and green lasers. If you want, you can try also some other lights, and definitely many more sources to do this. And the 3D model will help to solve the alignment inaccuracy problem. So these are the references I have used to do this. Thank you for listening. Thanks.
How small to small particles? Talked about scattering by small particles. So how small could they be so that all this theory and everything?
It should be smaller than the wavelength of the light you will receive.
Much smaller or
Not smaller.
much?
If it's larger than the wavelength, then it turns into baseline. Any other questions? Okay, thank you.
Thank you, Debanjana. Now I would like to call our second presenter, Huzzat.
Good afternoon, everyone. I am Huzzat, currently in third year physics honors at Presidency University, Kolkata. Today, I'll be presenting studies on knee scattering using image processing software. In this whole topic, I will be covering introduction, theoretical background, objectives, experimental setup, methodology, and results. At first, introduction. What is scattering? As Debanjana has said earlier, scattering is basically a phenomenon where light changes its direction after colliding with a medium particle of a medium. Then there are various kind of scattering like Raman scattering, Lee scattering, Rayleigh scattering, etc. In what is Rayleigh scattering? Rayleigh scattering is basically here particle size is much smaller than the wavelength of the incident line. There is some Rayleigh formula which is I that is 1 by lambda to the power 4. Here I is the intensity as lambda is the wavelength of the incident line, and that is why we see that why our sky is blue and why during sunset why the sun turns red and etc. And mist scattering is where particle size is equals to the wavelength of the incident line or the greater than the wavelength of the incident line. And in mist scattering, their wavelength dependence with intensity is less smaller than Rayleigh scattering. Compared to Rayleigh scattering, the intensity dependence with wavelength is less smaller. And for mist scattering, we see in nature that why our sky clouds like white and fog turns white, etc. Then moving into like theoretical background, in 1908, scientist Gautam first proposed this mean scattering theory for scattering particle by scattering theory by spherical particles, and it is applicable. I have said that when the particle size is equals to the wavelength of the incident light or particle size is greater than the wavelength of the incident light, and the size parameter is x equals to 2 pi r by lambda. Here x is the phase of the wave and r is the radius of the spherical particle. We are considering this particle as a spherical thing. So, and lambda is the wavelength of the incident light. And for Rayleigh scattering, the x is less smaller than 1. And for mist scattering, x is equals to 1. And this mist scattering theory is derived from Maxwell's equation with some certain boundary conditions for a sphere, and I have said that mist scattering wavelength dependence is much weaker and more complex than Rayleigh scattering. And then we are moving to objectives. My objective is here to analyze wavelength dependence and particle size effects using calibration and intensity plots, and to validate experimental results with some theoretical predictions, and to explore the influence of particle size on scattering slope variations. And every time when our teacher teaches us that what is scattering, Rayleigh scattering, mist scattering, and etc., we can see that the teacher just studies as a theory. They teach us as a theory. But if we see in the physical world what is happening outside, if we see that in classroom, we can demonstrate this by a smaller, like in small thing, what is actually happening in mist scattering, what is actually happening in Rayleigh scattering. This is the theoretical presentation. This is the experimental presentation in front of you that we can rememorize it, because whenever I am studying anything, we can't memorize things of what is happening. But if we see that experiments in front of our naked eyes, then we easily can memorize all these things in our mind. And then that is why this is very handy experiment that I have done, and then to get easy validation for theoretical proofs. And this is the optical path which I have used in my experiments. And these two are the experimental setup. Here I have used this like filament light, the slit, both two lasers, biconvex lens, and grating the filament. First, during the experiment, first our sir suggested that to use helium discharge lamp, but we find that line spectrum of it, but we could not catch it by our phone camera to detect the spectrum. Then we thought that we can move with like white torch, but the band spectrum of the white torch was not continuous at all. So we got like blue, green, and red. In between blue and green, there was a black spot. In between green and red, there was another black spot. We are dealing with wavelength, but if we get some discontinuous band, then we can't work on it. So I use this filament light to experiment to get the band spectrum of it. Then I have used there two lasers, which is green and red. There was another story that first I have used this green laser only. Then to derive some mathematical equations and all that, that was not easy to calculate, because there we have to measure things like slit, distance between slit and biconvex lens, distance between biconvex lens and grating slits, and also. Then we thought to experiment this. If we use the both two lasers, then we can easily get the calibration thing. And then I have used this biconvex lens, and this was the grating slit. And this grating slit also made by scratch, because we in our early days we have seen some compact disc in our house. That specimen of some compact disc, and without the gray coating it turns a grating slit. And this is the grating slit here, and I have put it like transparent cuvette in it, and there was some plain water. That was a solution for Rayleigh scattering. And for knee scattering, I have used the Dettol water solution. As we know, that Dettol is a colloidal particle. And then I have that optical arrangement is like filament, light, sample, slit, convex lens, grating slit, and scattered light detection. Then I detected this whole thing in my phone camera, and I have used this image.exe software for my data analysis. Then methodology is first, I have from this setup, I have gotten this spectrum. This is the band spectrum, which is very continuous, and this is the white light, filament light, and this is with that grating slit. I have gotten this blue, green, and red band. And then this is the calibration picture. Here I am getting that green, red. We are using the calibration thing because here we know that we are considering that red light wavelength is around 650 nanometer, and green light wavelength is around 520 nanometer. And then we process, like I plotted a line of it. Then through the line I have gotten that gray value versus distance value. Gray value is nothing but intensity here. And this is the white light. This is the white light. This peak is showing the white light. This is the blue. Here is here and here. This is showing blue. And then green, corresponding green, and then red. And then I have gotten this gray value versus pixel value. Then I have converted this with a simple equation that I am considering that wavelength is directly proportional to the pixel values. Then with these both equations, I have plotted intensity versus wavelength. And then I have done that I by I naught versus lambda, which is intensity ratio versus wavelength. As I am doing intensity ratio, I am considering intensity ratio as because every time, whenever I am doing the experiment, every time same amount of photon is not coming out from the filament light. Just because of this, I have taken ratio of intensity ratio. Then we know that in Rayleigh theory, I varies 1 by lambda to the power 4. If I take log of it, then I got that log of intensity equals to minus 4 of log of lambda. And this minus 4 is the slope here. And there I have done this just to get the slope. And this slope will give the dependence of wavelength with intensity. And then fitted the data using linear regression to determine the slope. And then I have compared slopes for Rayleigh and knee regimes. And then I have done this particle sizes estimation by DLS measurement. DLS measurement is like dynamic light scattering. Here it is to measure the particle size of a sample. Dynamic light scattering does it considers the Brownian motion of a particle. Then it find out the particle sizes of the sample. And then I have interpreted this is the results which I have done. Like this is the Rayleigh scattering, where in the cuvette that was only a plain water in the solution. I am considering just plain water, and then I have gotten the value is around minus 3.67, which is considerably 4. I am considering that the slope is around minus 4, and this is the Rayleigh. Intensity ratio, log of intensity ratio versus log of lambda. And then in the normal water, I have done a drop of water, drop of Dettol in the water. Then I have got the slope is around minus 1.35, which is I am increasing the particle size. Then I have seen that intensity ratio versus log of intensity, log of wavelength, we are getting the slope is around minus 1.35. I am getting that is less negative than compared to Rayleigh, it is less negative. Then I have done, I put it 2 drops of Dettol in the water. Then I have gotten the value is around, slope is around minus 0.96. Then for 3 drops of Dettol in the water, I have gotten the value is around minus 3.09. If I increase the particle size, I mean if I put 5 drops of Dettol in the solution, then I can get this slope around 0. And this is showing the mis-scattering effects. And then I have done with some particle size versus slope, which is considering that I am doing that Rayleigh scattering for plain water. And for plain water, I am considering that the particle size is around 0 nanometer, and then I have gotten the slope is around minus 3.67. And then for my particle size is 116. I have gotten the slope minus 1.35, and then the size is around which was previously mentioned here. Size is 134.05 nanometer. I have gotten the slope is around minus 0.96, and then for the value particle size is 218.15 nanometer. I've gotten that the value is around minus 0.35. If I increase the particle size more, the graph will saturate at 0 because the wavelength dependence is less weaker for mis-scattering. And then I have successfully obtained the scattering images, then calibrated first with 2 lasers. Then I have got that Rayleigh slope is around minus 4, and we are seeing that these slopes is less negative and indicated larger particle scattering. And then there were some challenges during the experiment, as there was low light intensity for scattered beam. I have said that firstly I have used helium discharge lamp. The intensity was so less, and then normal torch, and I have done this experiment on a darkroom setup, but little bit of light interference was there. This might be a challenge for sure. And then this was done on a normal blackboard, and so precisely line alignment was there also, and data noises from camera sensor was there. And then after some times we know that in a solution particle gets suspended over there. So every time when I have done like 1 drop of Dettol in the solution, 2 drops of, every time I'm just solubling this to get the perfect results. And then I have done this on a same sample. Like in Rayleigh, there is a cuvette. In Rayleigh, I am taking that from a same sample. I'm doing Rayleigh and me. That might be an error for this experiment. Then mis-scattering applications is in various stages, like in meteorology, aerosol and cloud studies, and for raindrop detections, and optics and photonics in optical devices. Mis-scattering applications is also there, and photo detectors, light sensors everywhere. And in nanotechnology, material sciences, geological sciences, biomedical field, everywhere, mis-scattering applications is also there. And conclusion is like I have successfully demonstrated this Rayleigh and mis-scattering mechanisms, and DLS result agreed well, and highlighted the importance of wavelength and light scattering phenomenon. This is the picture where I had used that white torch, because that picture was not continuous at all, because this is showing that there was some black spot in between blue, green and red band. So, and this is like with one using of one laser, I have done this, and this is the picture first. Then I have taken that picture. I said earlier that this is the particle size determination by DLS measurement, and my future work might include around. I took the picture at around 90 degrees, but my future work might include around 135 degrees, 180 degrees, and etc. And for polarization studies, investigate effect of incident light polarization on scattering pattern. And for particle characterization, I have taken that here the particle is the only colloidal one, but in egg white, in milk water solution, in aerosol, I can take this. I can make sure this experiment can goes through, and then quantitative improvements, like I can use higher resolution camera for this band image, and then improve the calibration to reduce error to error in pixel to wavelength conversion. Then study on refracting index by using different solvents like water, glycerol, alcohol, and etc. And this is the references which I have used during my home intensive work. And thank you.
Please go to page 4. Incredible Mukherjee derived from Maxwell's equations with boundary conditions for sphere. This scattering of particle size is comparable to
For the
wavelength of light. Rayleigh scattering is much less than wavelength of light. সেখানে আমি তোমার টপিকটা জিজ্ঞেস মানে এখানে তুমি যদি কথাটা লিখেছো তাহলে ওই র্যালে স্ক্যাটারিংটা কি ম্যাক্সওয়েল ইকুয়েশন থেকে ডিরাইভ করে যাবে?
হ্যাঁ, র্যালে স্ক্যাটারিংও তো ম্যাক্সওয়েল ইকুয়েশন থেকে ডিরাইভ করা যায়।
Just it was not said. So it's not size dependent. এটা কি তুমি করছো স্ক্যাটারিং, র্যালে স্ক্যাটারিং, স্ক্যাটারিং হচ্ছে ওখানে স্ক্যাটারিং ক্রস সেকশন ব্যাপারটা থাকে সিগমা বা এসব মনে হয়
না।
তোমরা জাস্ট এই স্লো
সো জাস্ট ভ্যালিড করেছে, মানে থিওরিটিক্যাল প্রুফ করেছে
না, এগুলো স্ক্যাটারিং এর ফর্মুলা আছে।
হ্যাঁ,
স্ক্যাটারিং ক্রস সেকশন ফর্মুলা আছে, কিন্তু বোধহয় সেগুলো তোমরা এই সেটাকে মেজার করতে পারো
না, এই সেটা
সেই জন্য
হ্যাঁ, সেটা খুবই হ্যান্ডি, মানে ক্লাসরুমে আমরা ডেমনস্ট্রেট করতে
সেটাই বলছি এটা অহ্যান্ডি, কারণ শুধু আছে ক্রস সেকশনের এক্সপ্রেশন আছে সিগমা। তো ফর এক্সাম্পল যেগুলো অ্যাপ্লিকেশন তুমি বলছো অ্যাটমসফিয়ারে এই সময় র্যালে স্ক্যাটারিং এর জন্য তো নীল আকাশ থাকে, তো আকাশের মানে এই বিশেষ ওয়েভলেন্থে স্ক্যাটারিং ক্রস সেকশন ডিপেন্ডেন্ট আপন ওয়েভলেন্থ। আকাশ নীল হওয়ার কারণ হচ্ছে ক্রস সেকশনটা ওয়েভলেন্থ ডিপেন্ডেন্ট ক্রস সেকশন। আর এক্সপেরিমেন্টের পার্টিকেল সাইজ কি করে কন্ট্রোল করা হচ্ছে, বিভিন্ন পার্টিকেল সাইজ এর ডেটা নিয়েছে, ডেটালের কনসেন্ট্রেশন কমে বাড়ে।
হ্যাঁ, ডেটালের কনসেন্ট্রেশন বাড়িয়েছি। ফার্স্টে আমার নরমাল প্লেন ওয়াটারে
বাড়ালে সাইজটা বড় হবে।
হ্যাঁ, বাড়ালে আমি ওটাকে সলিউবল করেছি, তারপরে কোলাইডাল পার্টিকেল দিয়ে ওটা কোলাইডাল পার্টিকেল ফর্ম করছে, তো পার্টিকেল সাইজটা ওয়েভলেন্থ থেকে বড় হচ্ছে।
কোলাইডাল পার্টিকেল মানে কি? আমি যখন বাড়িতে যখন কোলাইডাল এর মধ্যে ডেটা সেটা পুরো তো নিয়ে যায় পার্টিকেল ওরা কি করছে
কোলাইডাল পার্টিকেলটা বুঝলাম কি করে যে আমাদের একটা এসে
প্রচুর পরিমাণে ডেটা হচ্ছে এরকম আলাদা আলাদা স্পেক্ট্রাল।
আর আর এটা তো খালি চোখে আমরা দেখতে পাচ্ছি না, মানে এটা তো ওই ডিএলএস মেজারমেন্টে তো করছি, মানে পার্টিকেল সাইজটা মেজার করছি, ওটা ডিএলএস এর মাধ্যমে। আমরা এমনি তো খালি চোখে তো হ্যাঁ ডিএলএসটা করেছি। হ্যাঁ আর ওটাই পার্টিকেল সাইজটা দেখিয়েছে যে আমার পার্টিকেল সাইজ, আমি কনসেন্ট্রেশন যখন ডেটাটা বাড়িয়েছি পার্টিকেল সাইজটাও বাড়তে গেছে।
এটা তো রিটার্ন ফাইল মানে বারবার কনসেন্ট্রেশন বাড়ছে।
যেটা জানতে চাইছিলাম, তোমরা সেটা জানো না, এই যে সাইজ ডিপেন্ডেন্ট একটা সাইজ হলে নি হয় আর একটাতে র্যালে হয়, ওগুলোতে থিওরিটিক্যাল ডিরাইভেশনটা পড়ো ক্রস সেকশন,
না
মানে ম্যাক্সওয়েল ইকুয়েশন তোমরা পড়ছো আর
হ্যাঁ
ম্যাক্সওয়েল ইকুয়েশনের থেকে ডিরাইভেশনটা তোমরা শিখো, ডিরাইভেশনটা পড়লে কোনখানে ওই জিনিসটা আসে পার্টিকেল সাইজের জিনিস, এই একটা জায়গাতে নি হবে মানে তার নি ক্রস সেকশন হবে, সো এইগুলো পড়তে পারো। Jackson's ball is an important reference. Advanced interpretation. এছাড়া রজার নিউটনের একটা বই আছে আমার প্রশ্নটা কি করেছিল
ওই ক্রস সেকশন
দেওয়ার চেষ্টা করবো যে ম্যাক্সওয়েলের ইকুয়েশন থেকে যখন সিগমা বলে এটা টোটাল ক্রস সেকশন নিয়ে যখন ডিরাইভ করা হয়, সেখানে নিশ্চয়ই ডিরাইভেশনের মধ্যে একটা কিছু পার্টিকুলার সাইজের ব্যাপার আছে, যে কারণে একটা ক্ষেত্রে এটা এক্সপ্রেশন আর সাইজ অন্যরকম বলে একটা এক্সপ্রেশন। I would suggest that you study this on your own, practice from this. ঠিক আছে,
এখানে ম্যাক্সিমাম ভ্যালু 218 ন্যানোমিটার আছে, এই যে যেটা আমি দেখিয়েছি। ওখানে 3টে ড্রপ নিয়েছি, এর থেকে বেশি নিলে তো ইয়ে করে যাবে, স্যাচুরেট করে যাবে, তখন স্লোপটা 0 হয়ে যাবে।
ইন্ডিয়ান ড্রপ কতখানি জলের মধ্যে ভালো হবে? সেটা তো
50 ml এর মধ্যে 3টে। Any questions?
cross sectionটা থেকে সব কিছু পাবো, সেকশনস বা এক্সপ্রেশন কি বলে না
এই সফটওয়্যারটা যেটা দেয় ওটা হচ্ছে জাস্ট অনলি ইন্টেন্সিটি ভার্সেস ডিসটেন্স, ওটাকে কোনো টার্মিনোলজি যে গ্রে ভ্যালু বলছে, গ্রে ভ্যালুটাকে ধরে নিচ্ছি ইন্টেন্সিটি, ওটা এটা শুধু ইন্টেন্সিটি ভার্সেস ডিসটেন্স। আমার একটা পয়েন্ট
আমরা can do whatever what it should produce itself, which is not
কত পেজ নাম্বার কত কোথায় আছে? এরর হচ্ছে যে আমি না না আমি এরর ক্যালকুলেট করি, আর এরর ওই যে পুরো সবটাই আমি বুঝলে যে আমি তো একটা বড় সেটআপের মতো যন্ত্রের মধ্যে হচ্ছি না, এক্সপেরিমেন্ট মিক্রো হ্যান্ডি যে হাতে করছি কাজে সে রাখছি রাখছি তো এটা আছে বড় এরর আমার এই এক্সপেরিমেন্ট স্যাচুরেট করে গেলে ওই যে ইন্টেন্সিটির সাথে ওয়েভলেন্থের কোনো ডিপেন্ডেন্সি থাকবে না। নিতে এটাই হচ্ছে থিওরি যে ইন্টেন্সিটির সাথে ওয়েভলেন্থের কোনো ডিপেন্ডেন্সি যেটা র্যালে আছে, র্যালের সাথে 1/11^4 আছে, তো নিতে হচ্ছে একদমই ডিপেন্ডেন্সি, ওটা 0 হতে হবে এবার কম, মানে 4 থেকে কম, মানে আমার স্লোপটা 4 থেকে কম, যেটা হচ্ছে ওটা ওই 3D প্রিন্টিং দিয়ে হতে পারে।
Thank you both Srikanth and Regashan for these two exceptional talks. So I would like to conclude today's session. The Presidency Society will be back with such interesting talks in the upcoming weeks. Thank you all for attending today's talks.